Hello, this is the Physics MC. All right, we're going to talk about Archimedes' principle, a buoyancy force problem today. So here's the problem. The question is, how much force would it require to lift a 60-kilogram ball that has a density of 6,000 kilograms per cubic meter from the bottom of a pool to the top of the pool? All right, so one thing about these types of questions, and a lot of types of questions in physics, is you want to think about the forces involved. All right. So it always helps to draw a free body diagram, diagram with all the forces involved. Um, and what I'm going to do here is I'm going to highlight this. So we have the force of gravity going down on this ball. It's pulling that ball down. We're trying to oppose gravity, so we're going to have to lift up against gravity. So our force going up is going to be lifting up. But there's also another force because it's underwater. Water is going to also push up on the ball as well, because the lower you go in the water, there's going to be more pressure as the depth goes down. As you go farther down in water, there's more pressure. So it's going to push that ball up and kind of assist you as you lift that ball rather than just lifting it without the water's help. So that's kind of nice. So that's a free body diagram. So the force required to lift the ball would equal the force applied, that force going up, would be the force of gravity minus the buoyancy force, because the buoyancy force, the force of the water, is actually helping you lift it up. All right, so what's the force of gravity on that ball? Well, the ball was 60 kilograms. The acceleration of gravity is 9.81 meters per second. So the force of the ball going down is 558.6 newtons, assuming I did my math right. So there's 556 newtons going down on that ball. All right, now the buoyancy force is going to help you lift that ball. So it's going to reduce that amount. So recall Archimedes' principle says that the buoyancy force is going to equal the density of the water, or density of the medium, in this case it's water, times acceleration of gravity, times the volume of the medium displaced. All right, so density of water is 1,000 kilograms per cubic meter. Acceleration of gravity is 9.81. Volume of water displaced. How do we figure out that volume of water displaced? That's kind of tricky. Well, we know that the ball is submerged in water. It's completely under the water when we're lifting it up. So the volume of the water that's displaced is going to equal the volume of the ball that's displaced, or the volume of the ball, because the ball, as it's underneath the water, is going to go and displace that water. Um, so we can use the ball that's submerged. We can use an equation: density equals the mass of the ball divided by the volume of the ball, and that volume of the ball will equal the volume of the water. Um, so in other words, the volume of the ball is going to equal the mass of the ball divided by the density of the ball. Just rearranging that density equation for the ball. Density, mass over volume, or density equals mass over volume. So volume equals mass over density. All right. That's also going to equal the volume of the water displaced, because the ball, as it's underwater, is going to raise that water level up the same volume that it's under the water. So the mass of the ball, recall, was 60 kilograms. The density of the ball was 6,000. So we get 0.01 cubic meters. So the buoyancy force will be 1,000 um, kilograms per cubic meter density of water, 9.81 acceleration of gravity times the volume of water displaced, which is the volume of the ball, 0.01. Plug back into the equation, the force applied equals force of gravity minus buoyancy force. So the force applied is force of gravity, which is 558.6, minus, plug that in for the buoyancy force, 98.1 newtons. So the force required to lift that ball is 460.5 newtons. It makes sense that that force would be less than the total 558.6 newtons, because water's helping you raise it. All right. So I hope that helps. And that's been Archimedes' principle. And until next time, this is the Physics MC.